Hello everyone, I am from Sri Venkateshwara College of Engineering, name Rekha M, branch Electronics and Communication Engineering, section Infinity, semester 2nd, subject Basic Electronics in Engineering. Today I am going to explain about the concept of rectifiers. A rectifier is a device that converts alternating current AC to direct current DC. Rectifiers have two types, half-wave rectifiers and full-wave rectifiers. In full-wave rectifiers, again are two types, biphase rectifiers, bridge rectifiers. A diode is used to pass current in a single direction. Alternating current is a current which flows in both directions. In some applications, we need DC power supply. A method to obtain DC supply is by using batteries, but it is not economical at all times. It is possible to obtain DC from AC supply. That process is known as rectification. Rectification is of two types, half-wave rectifiers, full-wave rectifiers. In a half-wave rectifier, only one half cycle of AC voltage is used. Unlike a half-wave rectifier, a full-wave rectifier conducts in both half cycles of AC voltage. A full-wave rectifier can be implemented in two ways, biphase rectifiers, bridge rectifiers. Half-wave rectifier, positive half-wave rectifiers. An alternating input voltage is applied via or transformer T1 to a single diode connected in series with a load resistor RL. The diode is forward biased during the positive half cycles of the input waveform and reverse biased during the negative half cycles. Current flows through R only during the positive half cycles of the input. The voltage waveform developed across RL is a series of positive half cycles of alternating voltage with intervening very small negative voltage levels produced by the diode. Reverse saturation current. Operation of half-wave rectifiers. Positive half-wave rectifier, negative half-wave rectifier. Waveform of half-wave rectifier. The diode is forward biased. The voltage drop across it is Vf and the output voltage is minus Vf. So, the output voltage Vpo is equation Vpo equals Vpi minus Vf. That Vpi equals 1.414 Vi is the RMS level of the sinusoidal input voltage to the rectifier circuit. The diode peak forward current is equation Ip equals Vpo divided by R1. During the negative half cycles of the input, the reverse bias diode offers a very high resistance, so there is only a very small reverse current IR, giving an output voltage equation minus Vo equals minus IR R1. The diode is reverse biased. The peak voltage of the negative half cycles of the input is applied to its terminals. Thus, the peak reverse voltage R, peak inverse voltage PIV applied to the diode is equation VR equals PIV equals VPI. The average and RMS values of the half-wave rectified waveform can be determined as VOAVE. Next, negative half-wave rectifier. Reversing the diode polarity to the circuit, the negative half cycles of the AC input is passed to the load resistance. Diode is reverse biased during the positive half cycles of the transformer output, so the load voltage is 0. The negative half-wave rectified waveform can be generated simply by grounding the positive output terminal of a positive rectifier circuit. A positive half-wave rectifier circuit with a positive output terminal grounded. The AC input to the rectifier circuit is normally derived from the secondary of a transformer. The rectifier circuit output terminals may be grounded only when the transformer is present to provide complete DC isolation from the AC circuit. Next, full wave rectification. In this, two diode full wave rectifier. The full wave rectifier circuit in figure uses two diodes and its input voltage is supplied from a transformer T1 with the center tap secondary winding. The circuit is essentially a combination of two off-wave rectifier circuits, each supplied from one half of the transformer secondary. Operation of full wave rectifiers: positive half wave full wave rectifiers, negative full wave rectifiers. Waveforms of full wave rectifiers: when the transformer output voltage is positive at the top, the anode of D1 is positive and the center tap of the transformer is connected to the cathode of D1 by RL. The output waveform is the combination of the two off cycles, that is, a continuous series of positive off cycles of sinusoidal wave. This is positive full wave rectification. IL flows from the bottom terminal transformer secondary through diode D2 through RL from top to bottom and back to the transformer center tap. The negative off cycle of the transformer output, the polarity of the transformer secondary voltage causes D1 to be reverse biased and D2 to be forward biased. Next is bridge rectifier. The center tap transformer used in the circuit of figure is usually more expensive and requires more space than additional diodes. Bridge rectifier is the circuit most frequently used for full wave rectification. The bridge rectifier circuit in figure is seen to consist of four diodes connected with their arrowhead symbols all pointing toward the positive output terminal of the circuit. Diodes D1 and D2 are series connected as are D3 and D4. The AC input terminals are the junction of D1 and D2 and the junction of D3 and D4. The positive output terminal is at the cathodes of D1 and D3 and the negative output is the anodes of D2 and D4. During the positive off cycles of the input voltage diodes D1 and D4 are in series with RL. Low current IL flows from the positive input terminal through D1 to RL and then through RL and D4 back to the negative input terminal. The direction of the load current through RL is from top to bottom. The positive input terminal is applied to the cathode of D2 and the negative output is at the D2 anode. So, D2 is reversed bias during the positive off cycle of the input. Similarly, D2 has the negative input at its anode and the positive output at its cathode during the positive input off cycle.